morning, students. Welcome back to science class on the chapter force. In the previous class, we had discussed some problems. So already I have told, right? Today I will ask questions and give answers in the comment box. Okay. First question. First I will write. Okay. One. Why a passenger in a train falls backward when the train suddenly moves forward. When the train suddenly moves forward. Yes. Okay. Yes. See, your question is here. Why a passenger in a train falls backward when the train suddenly moves forward? Okay. Yes. Send answer for this question quick. I'll wait. I'll give you 2 minutes. I'll give you 2 minutes time. First. Due to inertia. Yes, correct. Sangeeta, here you answer due to inertia. No, tell me the exact reason. That is correct. Due to inertia. Okay, the answer is correct. But I need exact answer. What is the reason? Yes, first. Here, Akkamadevi Patil answered. The tendency of a body maintained to be in the state of rest. Wait, why a passenger train falls backward when the train suddenly moves forward? Why a passenger? See here. Yes, you are right. Okay, why a passenger in a train falls backward when the train suddenly moves forward? So that is due to the. Yes, your answer is correct. And one more, the passenger tends to remain at rest. Yes, this is also correct. Okay. See here, initially here that train at rest, and that passenger is also at rest. Okay, here that loco pilot will apply the force to the train, not for your body. So that's why that train it changes its state from rest to motion. But no one is applying force for your body. So that's why your body is at rest. So then your body it tends to remain at rest only. Okay. So due to the application of force, that the train moves forward. But you know, right? Your body is contact with the train. So your lower body which moves along with train. Okay, but upper body is not contacted, so that's why your upper body it tends to remain at rest. Okay. Yes. Good. Yes. Due to Mr. Srishailiyam, you answer due to the law of inertia. No, what is that? Okay. Yes. Second one. Second one. See here. Next question. Uh, a bullet fired at a person from a gun causes serious injury, whereas bullet thrown at the person does not harm him. Why? See here, you know that bullet. First, just fire that bullet. Sorry, a bullet fired from a gun or pistol. Okay, it harms the person. But instead of that gun, just I'll take that bullet and throw it to your body. It does not harm him. So here, give the answer and why. Okay, bullet fired at a person from a gun causes serious injury. It may kill, not only injury. Okay, this is chances for death. Okay, next serious injury. Whereas a bullet thrown at the person does not harm him. Why? Yes, I'll give you 2 minutes time. Quick. Yes, here 2 students answered. So bullet fired from a gun contains more velocity than the bullet thrown. Okay, it doesn't have more velocity the bullet thrown. Yes, both the answers are correct. Okay, because the bullet's force more from gun is less velocity than the bullet thrown. Yes, correct. Okay. Yes, what about others? Only 3 students answered. Sorry, one. Yes, only 3 students answered. What about others? Quick. I'm waiting for your answer. Fast. Yes, fast. Yes, because the bullet's force from gun is less velocity than the bullet thrown. Okay. Yes. What about others? Only 3 students are answering. Only 3 students are giving answer. Quick. I'm waiting for your answer. See here, see, while just mentioned that bullet is coming from a gun, so it is coming from that gun or see that bullet while coming from a gun or pistol, it comes with a huge amount of velocity. It comes with a huge amount of velocity. See, which cause that bullet causes serious injury. Why? Because right, this formula P is equals to m into v. Okay, here this velocity is more. This velocity is more. Why? Because it is while coming from the gun. Means its initial velocity is more. So that's why it gains more momentum. That bullet gains more momentum. So that's why it causes serious injury. But instead of that bullet or instead of that pistol or gun, if you throw that bullet, you can't throw that bullet with a huge amount of force. What you are getting, what that bullet is getting from that gun. Okay, so when you throw that one, when you throw that bullet, its momentum is less. Its momentum is less. Principle of conservation of momentum. What is the principle? What is the principle of conservation of momentum? What is the principle of conservation of momentum? Quick. Yes, I'm waiting for your answer. Sir, it's loading, sir. I think the data access from your mobile I think is less. Okay. Just turn off your mobile's data and turn it on. Okay. Or just put one's aeroplane mode. Just refresh your data. What is the principle of conservation of momentum? What is the principle of conservation of momentum? Okay. Yes, I am waiting for your answer. What is the principle of conservation of momentum? Yes, so sum of two objects before collision is equal to the sum of the two objects after collision, correct? When the initial momentum is equal to the final momentum. Very good. Sangeeta and Nitin Kumar. Okay, your both answer correct. Okay, so the total momentum before collision is equal to the total momentum after collision. So that is the principle of conservation of momentum. Okay, so what is that? So total momentum before collision is equal to the total momentum after collision. Okay, next one. So next one, which of the following, carefully, which of the following has more inertia? Which of the following has more inertia? Which of the following has more inertia? A rubber ball, and a stone, and a stone, and a stone of the same size. Okay, a rubber ball and a stone of the same size. So out of these two, now a rubber ball and a stone. Here the masses are same. Okay, so now tell me which has more inertia, a rubber ball or? Yes, Shruti answer what the stone has more inertia. Okay, so can you give why that the stone has more inertia? Yes, stone correct. Give the reason why that the stone has more inertia. Next one, I will write one problem. So find the answer for this question. Okay. Yes, okay, correct. Because it has more mass than the rubber ball. Okay, see here that rubber ball and stone both are same size. Size is same, but mass is different. Okay, so if the same sizes are same, but mass is different, right? So that stone it has more mass. So that's why it has more inertia. If the mass is more, then inertia is more. Mass is nothing. Sorry, inertia is a sorry, mass is nothing but measure of its inertia. Okay. Next one. Yes, find the answer for this question. Quick. A bullet flying with a velocity of 50 meter per second hits a block of wood and penetrates through a distance of 2.0 meter before coming to rest. The mass of the bullet is 0.03 kg. Calculate the resistance offered by the block of wood. Is faster. A bullet is flying with a velocity of 50 meter per second, hits a block of wood and penetrates through a distance of 2.0 meter. Okay. Before coming to rest. So here we can say that finally that object it will come to rest. Okay. So the mass of the bullet is 0.03 kg. Calculate the resistance offered by the block of wood. You know, right? Just imagine this is a block of wood. Okay. This is coming. Okay, so it penetrates through this block of wood and it will comes to rest. Why? Because here that bullet it applies force on this block of wood. Even this block also applies a force on that bullet. So that's why that bullet finally comes to rest. So calculate to come to that bullet. You know that block of wood it brings what that it brings the that bullet from motion to rest, right? To bring from motion to rest it should apply a force. So calculate that force. MD Patil, you are saying now good morning, sir. Already 26 minutes 45 seconds are over. Ah, yes, I'm waiting for your answer. Quick. Here, so its initial velocity, that is u is equals to 50 meter per second. Okay, then when it is to a distance, that is s is equals to 2.0 meter, and it coming to rest. Coming to rest means what? Its final velocity is equals to 0, right? So v is equals to 0, and its mass, that is m is equals to 0.03 kg. Here we need force, right? Yes, to calculate force, we know the formula, that is F is equals to m into a. We know the mass, but here we don't know the acceleration, right? Yes, first calculate the acceleration. How to calculate that acceleration? You know, here they have given some means to calculate acceleration: initial velocity, distance, and final velocity. Using these physical quantities, we can calculate acceleration. Okay. See, here we know the formula: v is equals to u plus at. Here we can't, because we don't know the time. Next, yes is equals to ut plus half at square. Here also we don't know the time, so we can't use this one. We have one more formula, that is b square is equals to u square plus 2as. Here we know b value, u value, and s value, right? So using that formula, find the acceleration. Okay, find the acceleration. So v square is equals to u square plus 2a. Yes, we need a, right? Bring u square this side, that is v square minus u square equals to 2as. So then we can write v square minus u square divided by 2s is equals to a. Okay, or we can write a is equals to v square minus u square divided by 2s. Now substitute the values and tell me what is the acceleration. Quick. Substitute the values and tell me what is the acceleration. Substitute the values and what is the acceleration. Yes, acceleration is 2.5 meter per second square. Okay. Yes, wait. What about others? So 0 and u is 50 square divided by 2 into 2. Okay. Yes. So a is equals to 0 minus 50 square. What is the 50 square? That is 2500. Minus 2500 divided by 4. Then a is equals to minus 2400 divided by 4. So what is the answer? Yes, quick. Two 2500 divided by 4. Sorry, here the distance is not 2 meter. Okay, extremely sorry, the distance is 0.2 meter. 0.2 meter. So distance is 0.2 meter. Okay, so here 0.2. It's not up to 0.2 meter. I'm extremely sorry. No, it's not minus 625, because here the distance is 0.2 meter. Okay, just correct it, 0.2 meter. So now 2 into 0.2. Okay, so what is the answer? 2 into 0.2, that is 0.4. Okay, 0.4. So A is equals to minus 2500 divided by 0.4. So better into 10 and here also divided by 10. Okay, so the answer is minus divided by 25,000 divided by 4. So now calculate. Okay, yes, so here what is the answer? I write here. So acceleration equal to minus 6, I think 6250. 6250 meter per second square. Okay, if the acceleration is 6250 meter per second square. Yes, correct. Minus 6250 meter per second square. Correct. Okay. So now here we got a minus, right? Why? Because that applied force is against the direction of that bullet. Okay. Calculate force. Now calculate force. So to calculate force, we know the formula, that is F is equal to m into A. Mass is 0.03 into minus 6250 minus. So tell me the answer. 0.03 into minus 6250. So what is the answer? Yes, here come on the particular. So F is equals to minus 187.5 Newton. Correct. The answer is minus 187.5 Newton. Exactly right. Okay. Cricket player. Why does a cricket player lowers his hand while catching a ball? Catching a ball. Yes. Tell me. So what is the answer for this question? Why does a cricket player lowers his hand while catching a ball? Yes, tell me what is the answer for this question? Yes, that F equal to minus 187.5. Yes, that question is over. Now this one. Why does a cricket player lowers his hand while catching a ball? Quick. Yes, here Sangeeta answered because the ball has more force with more velocity. Yes, correct. But I need exact answer. Why he lowers his hand? So without lowering your hand, you can catch that ball, right? So to decrease the momentum, yes, correct. Yes, hence the rate of change of momentum decreases. Okay. To decrease the momentum. Okay. How you will decrease that momentum? Yes, see here. Before catching that ball, you know that ball with a huge amount of velocity. Okay, so that's why it has more momentum. Okay. Yes, see here before catching a ball, that ball is coming with a huge amount of force. Okay, so a huge amount of velocity. So that's why its momentum is more. Here, that see that cricket player lowers his hand. Why? Because he is increasing the time. He is increasing the time. Why? To reduce the velocity of that ball slowly. Okay, he is increasing the time to reduce the velocity of that ball. Means so he is increasing the time to reduce the velocity of the ball to slowly. If you change, if you bring that ball from motion to rest suddenly, okay, it may hurt. There is a chances for dropping that ball. Okay, so that's why here he lowers his hands backwards. Why? Because he is increasing the time to decrease or to reduce the velocity of that ball slowly. When the velocity reduces, then the momentum also reduces, because P is equals to M into V. Okay, when you increase the velocity, then momentum increases. When you decrease the velocity, then momentum decreases. Okay, so here that cricket player lowers his hand while catching a ball, because here he is increasing the time to reduce the velocity of that ball slowly. So that's why if the velocity decreases, then the momentum also reduces or decreases. So then he can easily catch that ball. Okay, so this is the answer. I will stop here. Tomorrow I will continue the class. Thank you. Yes, here many students answered to decrease the momentum, correct. Because the ball has more velocity, so and to decrease the momentum, correct. Because the ball decreases the momentum. Because the ball decreases the momentum. Okay, the fielder increase the time which the is high velocity. Okay, your answer is correct, but that sentence is wrong. Okay, thank you. We'll meet in the next class.